In this video, we are going to discuss about boost converter. It is nothing but a step-up converter which used to convert the DC to DC signal. So you are having a input signal which is Vs. It's a DC, and the current flowing through this one is Is. It is also flowing through the inductance, so I can write Is of t is equal to IL of t. So this is your switch, and you have a diode and capacitance and a resistance. So what consider the Q is on. So when Q is on, when Q is on, the switch is closed. That is, switch is closed. Therefore, I can write this Vs is equal to VL, right? So whatever the voltage across this one is VL. Okay, so I can write this one, the voltage across the inductance, VL is equal to Vs. Okay, when the Q is on. Okay, so during that time the current through the inductance get increased, and there is no, since the whole current is flowing through this circuit, the capacitance current is there is no current flowing through the diode. So okay, so the diode current is 0. Okay, so we need to find the voltage across this I2, this resistance, okay, RL. So consider the desired voltage is somewhat like this. Okay, so this is your desired voltage V0. Okay, V0 is nothing but your V2. So I can form V0 by RL, that is nothing but I2. So the I2 current is like this. Okay, this is your I2 current. So we know that ID is equal to IC plus I2. ID is equal to ID is current is equal to I2 plus IC. So I can write IC current. IC current is equal to ID minus I2. So this is your ID current, and this is your I2 current. So what is IC? IC is nothing but minus of I2. So this is nothing but minus of I2 value. So this is about when Q is on. So what happens when Q is off? When Q is off, the switch is off means the moreover the IL of t is equal to ID of t, right? Because the current start to flow in this direction. So whatever the current here is same as ID. So you can see the IL current is same as ID. Okay, so if this is ID means what is IC? IC is nothing but ID minus I2. So you have to subtract this ID value from I2. So you will get the capacitance current like this. Okay, so you can see during this time, during this time, the capacitance start to as for this value. So during this time it is very less value, right? IC value is very less, and during this time the IC value is maximum. So I can draw that is the actual output. Okay, so the actual output is somewhat like this. So you are not getting the proper value. So let us derive the equation for V naught. Okay, so I can write Vs T on plus Vs T on plus V1 minus V2. V1 is nothing but Vs. Vs minus V2 T off is equal to 0. So if that is the case, Vs I can take it common, V2 T off. So what is V2 is nothing but V naught. So V naught, what is V naught? Vs T on plus T off divided by T off. So this I can write it as Vs into T. T is your T on plus T is nothing but T on plus T off. So what is T off? T off is equal to T minus T on. T minus T on. So if you take T common, if you take T common, you will get 1 minus T on divided by T. So what is what is T on divided by T? So V naught is equal to Vs 1 divided 1 minus D, because T get cancelled out, so you will get T on by T is equal to D. So next I need to find the value of inductance. We know that VL is equal to L di by dt. So when switch is on, you can write so what is the value when switch is on? When switch is on, there is this Vs. So Vs L del I divided by T on. So what is T on? T on is equal to L del I divided by Vs. So when switch is off, it is V1 minus V2. Okay, so V1 minus V2, that is equal to minus L. Why minus L means it is decreasing. Okay, so what is T of? T of is equal to minus L I Vs minus V2. So we know that T is equal to T on plus T off. So you take a del I common, so you will get 1 divided by Vs minus 1 minus Vs minus V2. So on solving, L di is equal to Vs minus V2 minus Vs divided by Vs minus V2. So that is equal to Vs get cancelled out, L del I V2 divided by Vs minus V2. So what is the value of L now? L is equal to T Vs minus V2 divided by del I V2. Sorry, here you have Vs, right? So 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 you have minus here, minus symbol here. So this is so I can write T into V2 minus Vs into Vs divided by del I V2. This is your L. So I can write T is nothing but V naught. It is nothing but V naught, right? Del I V naught. So we know that V naught by Vs is equal to 1 divided by 1 minus D. So I can write Vs is equal to 1 minus D into V naught. Sorry. So you can substitute in this equation V naught minus Vs into 1 minus D into V naught divided by del I V naught. So this V naught get cancelled out. So we know that the del I value, del I is nothing but del I is nothing but 2I2 divided by 1 minus D. Okay, so now you substitute this formula here. So V naught minus Vs into 1 minus D divided by 2I2 1 minus D into F. So if you take V naught common, you will get 1 minus Vs by V naught into 1 minus D the whole square divided by 2I2 F. So what is V naught by I2? V naught by I2 is nothing but your RL, and Vs by V naught is nothing but 1 minus D. So you substitute here. Into 1 minus D the whole square divided by 2F. So what is the value of L? L is equal to R RL 1 minus D the whole square into D divided by 2F. So if I want to find the value of capacitor, del Q is equal to C into del V, and we know that I is equal to dQ by dt. So what is Q? Q is nothing but integration of IC into dt. So I can write this del Q. Del Q is nothing but T on into I naught. Okay. So substitute C del V. C del V is equal to T on into I2. So what is C? C is equal to T on I2 divided by del V. see this I naught is nothing but this is your I naught. Okay, so I can write this del V, the area of this one. So this is nothing but T on, so this is nothing but your T on into I2. Okay, this is your area. So this is the value of your capacitor. Thank you.